Hello learners, welcome to another module of Introduction to Data Science using AI Assistant Tools. I am Dr. Vishwas KuKreti and today we will be understanding distributions. In the last few modules, we learned about data science, what data science is, visualizations, descriptive statistics, and we understood how can we use standard deviation, variance, and range to quantify our data. This brings us to our second metric of calculating the range or spread which is standard deviation. Now standard deviation is nothing fancy but just square root of the variance. So you see the formula tells us summation of xi minus x bar, which is again a fancy way to denote the mean, square them, divide by the number of observations and giving them a square root. Now standard deviation is the square root of variance, and which brings us back to the original units. So if we square root 14.69, we get rupees 3.83. Now our values are back in the units we are comfortable with. Rupees 3.3 has a meaning. Rupees square 14.69 do not. Now this tells us that standard deviations are much more useful in our daily lives. Now, but let's understand how do we interpret this standard deviation. What does rupees 3.83 mean? So rupees 3.83 means that the typical deviation is about rupees 3. It tells us on average prices vary by rupees 3.83 from the mean. Again, we are calculating these spread across our mean, our typical center point. So if your typical center point is rupees, let's say 0, on an average day you can find the prices to vary from plus 3.83 to minus 3.83 rupees. So the standard deviation tells us the typical daily price movement. Now how can we use standard deviation? Taking the example of our tomato mandi prices, we can say when the standard deviation is low, prices are stable and predictable. It's easy to know what prices am I getting tomatoes for. However, when the standard deviation is high, the prices are much more volatile, the prices have much more wild swings and the pricing can be risky. Vendors can use data science and hence use standard deviation to assess the market stability. If the standard deviation is low, they can be confident about that prices will be stable. However, if the prices are varying around, the standard deviation will be pretty high. Now let's look at an example and how can we calculate these values. Again, we can prompt ChatGPT to give us this code. So write a prompt which says given a data set, provide me standard deviation and varies in Python. So let's see, we have different prices, then we have a code which goes step by step. Now let's look at the different step through which this code goes. So the first step in calculating was calculating the mean of prices as we saw. So for our data points, the mean of prices remains 22.14. Then step 2 was calculating the deviation of each value from the mean. So we had different values, so 20, 22, 18, 25, 30, 19, 21. We subtract the mean, which is 22.1 from all of these values, which gives us different values with plus and minus signs. Step 3 would be calculating the squared deviations. We square all of these deviations and add them up. The sum of squared deviations becomes 102. The last point is to divide them by the number of observations, which is 7, which gives us 14.69. Today we will be moving across distributions. So as we remember, mean and standard deviation tell us about center and spread. However, they still have a problem. The standard deviation and mean tells you about how values are scattered around a center point. But we can ask the question, where do most prices actually fall? Do they fall near the center or are they across the data set? To use this, to understand the distribution, we use something called quartiles. So quartiles divide your data into 4 equal parts. Now what are quartiles? For example, take quartile first, which is the 25th percentile. If we divide our data into 4 equal parts, if we sort our data and divide it into 4 equal parts, the data which falls in the first 25th percentile, the first values would be, we will say it falls in the first quartile. It says 25% of the values fall below this quartile 1. quartile 2 is the 50th percentile or the median. It says 50% of the values in the data set fall above from this quartile and 50% of the values fall below this quartile. Similarly, the third quartile tells us the 75% of values fall below this particular quartile. So using quartile 1, quartile 2 and quartile 3, we can divide our data into 4 parts. So from 0 to 25th, 25th to 50th, 50th to 75th and 75th to 100th. Now let's take this visual example. You can see a whiskers different lines. So it tells the quartile 1. Quartile 1 tells you that 25% of the data is below Q1. Q2 is your median. 50% data or the middle value, 50% of the data is below Q2 and 50% is above Q2. Whereas 75% of the data is below Q3 and the rest of the values are much more above it. Now let's take an example and calculate quartiles. We have our sorted price, and this is the main point here. The prices here are sorted. So if we have prices as 18, 19, 20, 21, 22, 25 and 30. How do you calculate the first quartile? We can see that middle quartile is 21. Since it has 7 values, the fourth point is the median. So 50% of the values fall below rupees 21 and 50% of the values fall above 21, which are 22, 25 and 30. To calculate the first quartile, we can divide them into 1/4. So below rupees 19.5, we have quartile 1. Median is rupees 21 and quartile 3 is 23.5, where above which 75% of the values, 25% of the values lie and 75 of the prices lie below that. Now we have seen what quartiles mean. We can now interpret quartiles. So quartile 1 to quartile 3 contains the middle 50% of the prices. It shows where normal prices cluster and it helps us identify typical versus extreme prices. Now you see we can compare it to standard deviation and variance, where we are comparing spread across mean. Here we do not calculate spread across a mean, but we take the data points into value, which helps us identify typical or extreme prices. And it also tells us where normal prices cluster. Now this brings us to interquartile range. Now what is interquartile range? Interquartile range is the difference between quarter 3 and quarter 1. Now it is intuitive to see what this tells us. It tells us the measure of the spread of the middle 50% of the values. In our example, the interquartile range would be rupees 23.5, which is quarter 3, minus rupees 19.5, which is quarter 1. The interquartile range comes to rupees 4. So rupees 4 is where the spread, the middle 50% of the values deviate from. So the middle 50% of the values can deviate from rupees 21 plus 4 to rupees 21 minus 4. Now why interquartile range is useful? As you see, the interquartile range ignores extreme outliers. Instead of focusing on the extreme values as we did in the range, we focus on normal market behavior. Since we are only focusing on the normal market behavior and excluding the outliers, it is much more robust than range. If you remember, in range we pick up the maximum value and minimum value and subtract them to calculate the range. Instead of showing the extreme deviations, the interquartile range shows us the stable middle range. So a rupees 4 interquartile range tells us the middle 50% of the prices vary by rupees 4. So if the interquartile range is very small, it tells us the pricing is consistent in normal conditions. However, if the interquartile range is large, it tells us even normal prices vary very widely. Now we can also do a comparison between range versus interquartile range. So if we had to calculate range, the range would be rupees 12 as it included the extreme outliers. However, interquartile range is rupees 4 excluding the outliers. So the interquartile range is a much more metric to get a sense of the typical variation. In the last module, we even talked about an example where the tomato prices varied wildly due to a strike. We don't want to consider such values because they give us a skewed sense of the variation. In that case, interquartile range gives us a better sense of the typical variation across our data points. Now let's use a visual technique known as a box plot to visualize this spread. A box plot is a very interesting visualization which shows all spread measures in one chart. So it shows us the minimum values, quartile 1, median, which is the quartile 2, quartile 3, maximum. It's a great visual way to see the data distribution. As shown on the screen, there is a number line. So you would see there is a box from around 3.75 to all the way to 9.6, and there is a line in between. So for this, and the values vary from 2 to 15. In this particular example, the minimum value is 2 and the maximum value is 15, which is shown by the whiskers. There is a box. The first line tells us the lower quartile or the quartile 1, which here is 3.5. The median here is 6.1, which is shown as a dash in the box. The upper quartile is 9.6. Now the question here is, what is the interquartile range? As you can see, the interquartile range is very easy to calculate here. It's 9.6 minus 3.5. Now let's look at this box plot in much more detail. So the box really tells us the interquartile range, or the middle 50% of the data. The line inside of the box is the median. The whiskers, or the single line which vary from the box to either ends, show the minimum and the maximum values. Any dots beyond those whiskers tell us the outliers, which we should ignore. So now how do we read a box plot? If the box plot is wide, it tells us there is a high variability in the middle 50% of the values. However, if the box is narrow, it tells us the prices are clustered tightly. The long whiskers would tell us extreme values exist. Let's take an example of a box plot of our tomato price example, as which we saw in our last module. So you can see a box plot on your screen. It tells us the minimum value is rupees 18, the maximum value is around rupees 28, and the median value is rupees 21. The first quartile is 19.5 and the quartile 3 is around 23 something. So you can see, just using one visualization, we were able to display the spread of variability in tomato prices using just one visualization. Now let's calculate this in Google Colab. We'll use Python to calculate all measures. Type the code exactly as shown in the ChatGPT output. You take that output, go to Google Colab and paste it there, and press Shift plus Enter to run each cell. So the first part of doing this is to import the libraries. So if you are unaware of libraries, libraries are specialized modules which help us in certain functions. For example, NumPy is a mathematical library. It helps us do mathematical operations. Pandas is a dataset library which helps us to analyze data sets. Matplotlib.pyplot is a plotting library which plots visualizations. The second part is to create a dataset. So the prices are rupees 20, 22, 18, 25, 30, 19, 21, which is our tomato price data for 1 week. Now, how do we calculate this spread and measures? So Python provides you a way to calculate them easily. To calculate the mean, you can simply use np.mean. To calculate range, it's also pretty simple because it's a difference between the maximum and the minimum. So you say maximum of the prices minus minimum of the prices. Similarly, to calculate variance, you do not need to go all the 5 steps. You can simply use np.var to calculate the variance and np.std to calculate the standard deviation. To calculate the quartile 1, you should use np.percentile prices and the first percentile, which is your 25th percentile. The third is the 75th percentile, and to calculate your interquartile range, you can subtract the first quartile from the third quartile, which is np.percentile price is 75 minus np.percentile price is 25. Now this would tell us your entire spectrum of your range and measures. So the mean is around 22.14, range is 12, variance is 14, standard deviation is 3.8, quartile 1 is 19.5, quartile 3 is 23.5, and your interquartile range is 4. So this is also shown on your screen. Now we can compare the two mandis when we have this code. For example, for mandi A, if the mean was rupees 22, standard deviation was rupees 3.5 and an quartile range of rupees 4, whereas a mandi B has rupees mean of 22, standard deviation of 8.2 and an interquartile range of 11. They have the same average price but very different risk. So you would see for mandi A the standard deviation is 3.5, which means the prices stick to the mean price. So the maximum value you can expect on a normal day is 22 plus minus 3.5. Whereas for Mandi B, the prices vary wildly. It's much more volatile, as shown both by the standard deviation and interquartile range. So the Mandi A has a low standard deviation, low interquartile range. It tells you the Mandi is stable, is much more predictable. Compare it with Mandi B, its high standard deviation of rupees 8.2, much more volatile and risky. Now this is a question for you. Which one would you prefer as a vendor? You know both of those standard deviations. This can have further impact on inventory planning. If you have a low variability, you can buy bulk with confidence. However, if it has high variability, you will be hesitant to buy and will buy smaller quantities more often. So spread measure helps you choose the right strategy. It's the data which helps you calculate the spread, and the science will help you make that decision. Similarly, it can have an impact on credit and cash flow. High standard deviation markets need more cash buffer, whereas the low standard deviation markets allow tighter cash management. Understanding risk helps manage working capital. This can also impact your daily operations. If the variability is low, you can plan labor, transport, but if it's high variability, you need flexibility and backup plans. This leads us to risk assessment. Risk assessment is key to smooth operations, and you need your volatility matrix to calculate that. Now let's summarize our different measures of spread which we did in this module. So first was the range. It was very simple, where we calculate the extreme differences, maximum value minus minimum value. Variance is the average squared deviation, and standard deviation was the square root of variance. Interquartile range is the spread of the middle 50%, quartile 3 minus quartile 1. Now we can answer the question which measure to use when. When you want to use a quick sense of extremes, how much swing is in the prices or in the data points, you must use range. If you want to understand the overall volatility assessments during normal or typical days, you should use standard deviation. However, if you want to ignore the outliers and you want to calculate the behavior across normal days, you should use interquartile range. No one matrix is important or less important. Every question needs different measures. Always ask how spread out is the data. No single measure is perfect, and use multiple measures for complete picture. I'll leave you with one practice activity. So observe prices of any item in your local market, collect prices for 1 week, calculate the range, standard deviation and interquartile range. Now, reflection questions. Which spread measure would you trust most? Would you take range, standard deviation, interquartile range, or variance? Now, why would you choose that measure? There should be a logical reasoning to do that. Think about your local market conditions. That will be all for today's module. Thank you.